All right. Algebra 1. Notes. So this section is section 8.1, graphing parabolas. Now, if you want, you could do this on graph paper. There is a good amount of graphing, and graph paper just makes it easier. Makes it quicker, makes it look nicer. I'm just going to try and do it without graph paper right now. So write your name, date, period on it. And let's take all these notes. So graphing parabolas also f of x equals ax squared. So that's sort of what the equations of this shape called a parabola looks like. Let's go over a few couple things. We also call these quadratic functions. So quadratic functions, they have the degree of 2. Highest power on the x is a 2. Any equation that can be written in the form y equals ax squared plus bx plus c. So that's a quadratic equation. Looks like a trinomial, right? We were studying this last chapter. They're linear, or they're non-linear. They won't look like a straight line. They'll look curvy. Now, we're looking at a special case today of just this part. So the A, B, and C are just going to be numbers. So it's like the B is 0 and the C is 0. We're dealing with this special case today, and then we'll probably start to bring these in on future sections. Number 2. So the shape that this looks like is called a parabola. And it looks kind of like this. Very simple. It's like a U-shaped graph. Now, it might be going up, but it might be going down. So if A is positive, and A is the number in front of the x squared, so if that first number is positive, it's going to open up. Opens up. And maybe a little trick you can remember is that positive people smile. Looks like a smile. If A is negative, it's going to open down. Okay? So there's a negative number in front of the x squared term. That means it's going to look like a parabola, same shape, but it's going to be going down. Okay, number 3, the vertex. So the vertex is the lowest or highest point on the graph of a parabola. We might also say the minimum point or the maximum point. So minimum and maximum are fancy words for lowest and highest, smallest and biggest. Now, if the graph is opening up, it's going to be this point right here. This is called the vertex right there, and it's going to be the lowest point of the graph. It's going to be the lowest point. The graph just goes up forever. If it's upside down, if it's opening down, then the vertex right here is going to be the highest point, maximum. Now, the vertex is where the graph kind of changes directions. Like you could be like, well, it's going down and now it's going up. So it's sort of that turnaround point. Number 4, there's something called the axis, or they might call it line of symmetry. Symmetry means something has the same thing on one half as the other half. So it is the line that divides a parabola in half. And like on these right here, it'd be like a line like this. We usually draw it dashed. It's a vertical line. It's up and down. Okay, so let's go over some more what we would call characteristics. Characteristics. It's not going to be a lot of like work involved in this section. It's going to be more looking at a picture and identifying things, or drawing a picture, a simple picture. So characteristics of quadratic functions. Okay, characteristics of quadratic functions. The what we call it, the parent function. Parent function is parent quadratic function is f of x equals x squared. So you'll notice the difference up here is that there's no a right here. That means a equals 1. So this is like the main one, and all the other ones are based off of this. So all other quadratic functions are transformations of this graph. Okay, and we're going to graph it. Transformations are like changes to it. So like you could take the original graph and shift it left or shift it right. You can move it. You could shift it up, or you could shift it down. You could change, you could kind of squish it or stretch it. You can make it wider or smaller. So you can kind of like sort of change the way it looks. So let's go ahead and graph this original one. And this is where, if you have graph paper, you would still want to darken these lines in. Okay. These are called the axes, the x and y axes. Now I'm going to go ahead and sort of draw some grid lines in there real quick. If you have graph paper, then this is already on there. Now, so this is going to be your first parabola. It goes through the point right here, 0, 0. It goes through this point, negative 1, 1, 1, 1. And here, there's a kind of a simple shape to them. If you, however much you go over, you square it, and that's how much you go up. So if you go over 1, you go up 1 squared. If you go going back to the beginning, if you go over 2, you go up 2 squared. 1, 2, 3, 4. If you go left 2, negative 2, and you square it, when you square negative, you get a positive. 1, 2, 3, 4. So this is the most basic parabola. This is, they call it the parent function. You got to put arrows on the ends of the lines. Okay. Now there's some special things about it. This point right here is called the vertex. We talked about that. The vertex for this guy is at 0, 0. The line of symmetry we usually graph as a dashed line. So if it's right on top of the axis, you might kind of just make it a little bit to the side. Okay, so this is the axis, or they might call it line of symmetry. Short, they might call it AOS or LOS. Now, it's a line. It's a vertical line, and vertical lines have all the same x values, and it's going to be the same x value as the vertex. So it's going to be x equals 0. That's the equation of that line. So we don't just say 0, we say x equals 0, because that describes all those points right there. Now, this original graph, some other terminology we might say is that we might say that the graph is decreasing right here. Decreasing is a fancy word for getting smaller. The y values are getting smaller, going down. This is increasing, which means it's going up, or the values are getting bigger on that side. So this is the parent function. Now, what's going to happen is sometimes there's going to be something that changes the graph. And it might, I'm going to use a different color, different pencil or something right here. It might make it go like this. And it'll have the same shape, but it look kind of like squished, like kind of flat or wider. They might call that wider. And so, but what we call that is we say it's the graph. We shrunk the graph. To shrink the graph, or you might say it's wider or smaller. This might be different. Where it's now, it still goes through 0, 0. So this is the same. It still has the same axis symmetry, so that doesn't change. And then the other possibility is, so you'll look, it'll be outside this graph, it'll be bigger, like, but we can make the graph steeper, and then it kind of looks like it's inside the original graph, and it looks like it's stretched upwards, right? So we'd say stretched. I could spell right. Stretched or taller, bigger. Okay. Now it still has the same vertex 0, 0, still has the axis symmetry, still decreasing, increasing. So they all look kind of like each other, but that's why they call this original one the parent function. Okay. So let's try some. Okay, it's the directions will be identify the characteristics. Identify the characteristics. And I'm going to say characteristics, those are like the main things about it. So we're going to say we want the vertex, we want the axis of symmetry or line of symmetry, the AOS, we want the domain, we want the range. Okay, and we've talked about domain and range a while ago. So here's example 1. Now, on these ones, you're going to be given a picture that's already drawn. So for now, we're going to recreate it. So I'm going to just try and draw this roughly now. I'm going to make the X and Y axis stand out. Label them. And I'm going to draw some little grid lines here. Okay, so this one, the vertex is right here at -1, 1. Like I said, the shape, all these kind of have the same basic shape. I'll tell you how it gets changed. But usually it's over 1, up 1 squared, over 1, up 1 squared on both sides. And if you go left, it's like negative, but you square it, becomes positive. If I go right 2 from the beginning, I go up 4, 1, 2, 3, 4. Left 1, 2, up 1, 2, 3, 4. So this is the original, this is the graph that you'll have been given. We put arrows on the ends because that means it keeps going up and to the left and the right forever. So we want to figure out, well, what's the vertex? And so right here, you might go ahead and draw it on your picture if you have a picture, and the vertex is at -1, 1, but I'm probably going to want it listed somewhere as an answer. Okay, you put it on the picture, that's helpful, but let's also write it. So vertex, label it. You got to write as an XY pair, X first, Y second, in parentheses. The axis symmetry is what cuts it in half. And so right here, this is the axis of symmetry, and it's going to be X. It's always vertical. It's always going to be X's, and it's going to be the same X as your vertex. X equals -1. All these points have X equals -1. So the axis of symmetry is X equals -1. Don't put -1, put X equals -1. Okay. Now the domain are all the possible X values that get used. And these arrows mean it goes to the left forever and it goes to the right forever. So it's going to be all real numbers. Okay. There's a symbol that's short for that. And it looks like this. It's 2 vertical lines with a with the R. That also means all real numbers. The range is all the y values that could come out. Now, if you look right here, all the y values are above +1. So it's got to be y is greater than or equal to +1. That's the range. Now, the other thing I want you to identify, is the vertex a max or a min, a maximum or a minimum, the highest point or lowest point? And here, it's the lowest point. It's the minimum. So these are all your answers for this problem. That's identifying the characteristics. Let's try another one, and I'll let you guys try it on your own, but let's draw it first. So, on the homework, they might just give you a picture, and you don't have to redraw it. And if you do this on graph paper, it's a lot easier. Okay, this one, the vertex are going to go over 3 up 4. So this is going to be that point right there. And then this graph's going to go down instead, but it's going to have that same shape. Instead of going over 1 up 1, over 2 up 4, over 3 up 9, you can go over 1 down 1, over 2 down 4. Ooh, did I mess that one up? No, I think it's good. Over 1 down 1, over 2 down 4. So this is what the graph looks like. This would already be given to you. And when you connect these dots, it's a nice smooth curve. It's not a V. And we should put arrows on the ends. That means something. Okay. So we need the vertex. So this is the vertex right here. All right. It's that extreme point. And this one is at 3, 4. The x value is 3. The y value is 4. X first, y second. So 3, 4. Is it a max or a min? Last one was a min. It was the bottom. It was the lowest point. This one's the highest, the top. This is the max. Okay. The axis of symmetry. Well, that's going to be this line right here that cuts it in half. And it's going to be x equals whatever x values these all have, which is the same as the vertex. X equals 3. X equals 3. The domain, this goes left and right forever. So it's going to do every possible x you could ever think of. So it is all real numbers, or short. It's these two vertical lines with like a little r. The range is the y values. Now here the y values don't go up forever. The highest y value is 4, and then it goes down from there. So y is less than or equal to 4. Those are your answers. Okay? So you're going to have to do that. You're going to have to look at a picture and identify the characteristics. But you're also going to be given an equation and have to make your own graph. So let's do a couple of those. So the directions on these are going to be graph the function and then compare the graph to the graph of f of x equals x squared, the parent function. So we're going to graph the function, we're going to make a picture, and then we compare it. So we can kind of like talk about like how it's different. So let's go ahead and start with the parent function just to have, so the parent function is f of x equals x squared. Okay. And I kind of showed you guys kind of a little trick for getting the pattern, but there's some other things I haven't told you yet. So what might be better for now, if you have to make your own graph that isn't already there, is to make a function table. Okay. And we've done this before, and it's pretty straightforward. You just plug some different x's into this and figure out what the y's are, and then graph those pairs on your graph. So we can pick whatever x's we want, but it's usually nice to like kind of get a good picture of the graph. Some negatives, some positives, -2, -1, 0, 1, 2. And then we're going to plug these in. So negative 2 squared, the negative gets squared. Negative 2 times negative 2 is 4, positive 4. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2, 2 squared is 4. And we're going to graph that for each of these problems so that we can compare it. So example 3 is going to be gx equals 5x squared. And then example 4 is going to be mx equals 1/2 x squared. So it doesn't have to always be an f in front. They use other letters sometimes too. So we got two problems here. I'm gonna make this graph right here. You could, if you use graph paper, we could even print them out. You could like Google graph paper and just print it out on your printer or something like that, and then, or you could do like I'm doing. If you don't have it, don't have a printer, don't want to do that, you could just draw your own, but try and make it look nice. Okay, now I'm kind of making this one, so I got to draw my little grid here. And I guess you could use a ruler. You could just try and draw straight lines. Okay, so if we graph these, negative 2, 4, you go left 2, up 1, 2, 3, 4. Negative 1, 1, you go left 1, up 1. 0, 0 is right here. 1, 1, you go left, right 1, up 1. 2, 4, you go up over 2, up 4. It's that pattern, right? Isn't that pattern I'm showing you? And we're going to graph it. And we're going to put nice smooth graph, put arrows on the ends. Okay. So that's that graph. That's the parent function. Now, what's going to be helpful is if we do like a different color pen or a pencil instead. So, but I'm going to make a graph for this guy, or a function table for this guy. So I'm going to do the same values. -2, -1, 0, 1, 2. And I'm plugging them into here. So -2 gets squared as 4. Then you multiply it times 5 and you get 20. Don't do 5 times -2 is -10 squared, get 100. You got to do order of operations. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, last. So you got to do the -2 squared, which is positive 4 times 5 is 20. -1 squared is 1 times 5 is 5. 0 squared is 0 times 5 is 0. 0 times anything is 0. 1 squared is 1 times 5 is 5. 2 squared is 4 times 5 is 20. And you're going to usually see a pattern here where you're getting the same values on both sides. So let's graph these on this. So -2, 20. Oh my gosh, that's really big. I mean, I might not even have enough room here. I mean, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20 would be double that. So I'll see if we can figure. So -220 would be like all the way up here. -1, 5 is going to be right here. Left 1, up 5. 0, 0's there. 1, 5, you go right 1, up 5. 220, you go right 2, up 20. So that's going to be like way up here. And then we connect the dots with a nice smooth curve, not a sharp V down there. It's got to be a smooth curve. Got arrows on the ends. Okay, that's part of the graph that you need. So this first one was f of x equals x squared, and the second one is g of x equals 5x squared. Okay, now we're going to compare them by talking about their characteristics. So A is, how's the shape of the graph look of this one compared to that one? Well, we call it a vertical stretch. It looks like someone stretched it and it makes it look tall and skinny. Now, vertical stretch by a factor of 5. It's 5 times taller. That's what that number in front does. A number in front will multiply all the values you would normally get by 5. That makes everything 5 times taller. All the dots we got before are 5 times taller, which stretches it, okay, by a factor of 5. B, the vertex. Well, the vertex is right here. It's at 0, 0. And that's the same for both of them. They both have the same vertex. C, the axis of symmetry. The axis of symmetry is this line that cuts it in half, and that's x equals 0. X equals 0. And that's the same for both of them. So they're different, but there's also things that are the same. D, the domain. The domain is all real numbers, and it's the same for both of them. It goes left and right forever. That's what these arrows mean, okay? E, the range. The range are the y values. They're all positive. They start here at 0 and go up, so it's y is greater than or equal to 0, or equal to 0. And that's the same for both of them. So they have almost everything in common, except that that first one looks taller and stretched out. Okay? But that's what we're going to do on these. So let's do one more. So let's do example 4. Now, we're going to use the same parent function to start it off with, but then we're going to make a new function table for mx. I'll get to that in a second. Let's go ahead and draw the graph first. The parent function graph. So I'm going to do these on separate graphs. So you're going to draw your y-axis and your x-axis. Now we're going to keep these graphs pretty simple. We're going to get more into it in the next sections. Like they'll get harder, more complicated. Use graph paper, and you don't have to do any of this, and it comes out looking real good. Okay, so remember the parent function was -2, 4. Or remember the trick. It starts at 0, 0. You go left 1, up 1 squared. You go right 1, up 1 squared. You go left 2, up 2 squared, 4. You go right 2, up 2 squared is 4. Okay, so we're going to graph that first. I didn't really need to make a new function table for that. And then we're going to do this one. Now, this one, we could do -2, -1, 0, 1, and 2. But you might look at this and like think, well, what are some numbers that would give nicer numbers? Like, I mean, we're going to get fractions for this because it's 1/2 in front. But let's say if we picked -4 and -2, 0, 2, and 4, those, if you square them and divide by 2 or multiply them in half, they come out nice. So sometimes you might pick your values based off like how nice they come out. So if I do -4 squared, that's positive 16 times 1/2. The same thing as divided by 2 is 8. -2 squared is positive 4 divided by 2 is 2. 0 squared is 0 divided by 2 is 0. 2 squared is 4 divided by 2 is 2. 4 squared is 16 divided by 2 is 8. And again, we're getting these same values because that's the way the graph looks. So -4, 8, 1, 2, 3, 4, 5, 6, 7, 8. So -4 left 1, 2, 3, 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 7, 8 right here. Okay. And then -2, 2, you go left 2, up 2. 0, 0. 2, 2, you go right 2, up 2. Oh, wait. Right 2, up 2. That's the wrong spot. 4, 8, you go right 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. These should also be at the same level, so you kind of know if you did them wrong or not. Connect them with a smooth line. Arrows on the ends. That's part of the graph. Okay. So this is the original graph, f of x equals x squared. And this is the new graph, m of x equals 1/2 x squared. So let's compare the graph to the graph of parent function. So A, is it stretched? I mean, it looks kind of bigger, but it actually, look, all the points that line up with these are below them. In fact, they're half of them. That 1/2 in front multiplies all the normal y values by 1/2. So instead of getting 4, we got 2, right? And instead of getting, so it's actually kind of squished. It's like it's been shrunk. Okay, so we'd say vertical shrink by a factor of 1/2. Okay, vertical shrink. B, vertex. The vertex is 0, 0. And it's actually the same for both of them. No change. C, axis of symmetry. Axis of symmetry is this line right here. It cuts in half. It's x equals 0. All the values are 0. X equals 0. Same for both of them. D, domain. Domain is all real numbers. And it's the same for both of them. E, range, is the y values. They're all right. They start here at 0 and they go up. Y is greater than or equal to 0. And that's the same for both of them. So we're going to get in some where the graphs get moved around more and more stuff happens. But that's it today for your classwork. You can do the monitoring progress. Page 421, problems 1 through 9 all. If you do these with the Student Dynamic ebook online on Big Ideas website, these have little blue arrows next to them, and it'll show you exactly how to do the problem. So that might be good just to double check. I've seen some of you guys turn in monitoring progress that are all wrong, way off, and you could have figured it out, and now you're not ready to do your assignment. So that's it. Try these problems yourself now.